Okay, so let's go to hypothesis testing 2, large samples and Z-test. So, um, so for large samples instead of grand samples, we are going to use Z-test, and because of the central limit theorem, the guarantee that our results for using Z-test will be good. So let's look at a question. This question is the problem 2 in section 2 from worksheet 24. So this problem is if you flip a coin 100 times and get a total of 55 heads, can you see that the coin is biased toward head? We're giving the significance level of 0.05. So remember, this is a hypothesis testing. We need to first write the null hypothesis and the alternative hypothesis. So our null hypothesis in this case is that the coin is fair. And our alternative hypothesis is that the coin is biased toward head. And if the coin is fair, that means the probability of it gets a head is 0.5. And the central limit theorem tells us the percentage of coin flip we get is approximately normally distributed. And if we want to calculate the population standard deviation, the sigma, we are getting we are treating that the coin is fair. So the standard deviation of that would be PQ, where Q is 1 minus P. In this case, it's square root of 0.5 times 0.5. This is also 0.5, which is 0.5. And central limit theorem tells us what? The central limit theorem tells us that the mean would be equal to the population mean, which in this case is 0.5, and the standard deviation will be equal to the population standard deviation divided by square root of n, which is 0.5 divided by square root of 100 because we're doing 100 flips. So that would be 0.05 in this case. And we are given the fact that there are 55 heads. So we want to calculate the z-score of that. So that will be the z-score of 0.55, which is our measurement, minus the mean divided by the standard deviation. So that's the z-score of 1. And this is corresponding to 0.3413 if I look up the z table. So again, similar to what we did on the previous video, we calculate the p-value, which if you look at the curve, p-value will be the area here, and the z-score of 1 standard deviation of mean 0.3413 will be here. So the p-value will be 0.5, which is the whole area here on the right, minus 0.3413, which is 0.1587. But we know that we are given that the significance level is 0.05. And 0.15 158.7 is obviously greater than 0.05. So p-value greater than alpha, which tells us we cannot reject the null hypothesis. And that's the end for hypothesis type 2 large samples and the